In 2009, here with Mr. Stephen Leone, Georgia Trade School instructor, and what are we going to be working on today, Steve?
All right, so we're going to do a pretty standard test that carries over into the ironworkers or any structural D11 code, and that's a 1-inch bevel with a 30-degree groove angle on a backing strip. This is kind of the predecessor before you get into pipe. Obviously, if it's pipe, you need to do it open root, but this is kind of that typical structural 1-inch. Any contractor or good structural stick employer wants to see that you can fill this up with stringers, whether it be with 1/8 rods or 3/32 rods or 5/32 rods, all 7/18s. You want to learn how to run them all. All right, so basically what we'll do is we'll grind all the mill scale off of the bevel edge, the surface of the bevel, and the backing strap. And then depending on the bevel angle per the code book, for this being 30 degrees, we're going to be around 3/16, right under a quarter. And so obviously when we fit those up, they'll fit more flush like that. And then we'll just run stringers and fill it up.
Cool.
We've cleaned up our bevels, cleaned up the surface, cleaned up our backing strap. We've got about a 1/4 inch gap. That's what we're working with right now, 3/16 to a quarter. It's not super picky, right? Just a 1/16 of an inch difference. What we're gonna do now is we're gonna tack on the ends of these plates here and here while keeping pressure downward. Then we're gonna tack the top side, same spot. Then we'll flip it over and I'll show you how to run the tacks on the back side. So keep your pressure maintained. If you see anything weird happen, like a plate rise up off of the backing strap, adjust accordingly. But for the most part, you can keep your gap, keep pressure. Just put your tacks on the other side now. When I say tacks, I mean just little baby tacks, because if anything happens, the other side pops, you want to be able to just take your grinder to it relatively quickly. You don't have a big honking weld on there that you can't break off. On the back, you want to put about a 3/4 inch to a 1-inch weld, nothing serious, just enough to hold it in place. You want to alternate your tacks so the plate doesn't warp. Now we're going to go in the opposite corner here. I do want to say, before you do that, as you can see, that's a lot of weld on the back. Before you do that, that's why that front side is so important. You want to make sure that the fit up is tight, so that way, if you were to break a tack while doing this, you'd almost have to start over. So that's why that front side, you want to make sure that gap is aligned, the spacing is correct, the plates are flush and nice and tight, so that way you're ready to weld at this point.
That looks beautiful.
All right, so we're gonna run the root pass now. We're gonna fuse these 2 plates to the backing strap, all 3 of these members together. And what we're gonna do is we're gonna run a stringer straight up. You can oscillate it slightly if you prefer, or you can run it straight up. The gap is tight enough, that way you could run a stringer perfectly, but if you like to move it side to side, that is also fine. The goal here is, like I said, to fuse these 2 plates to the backing strap.
All right, do you have any tips you'd pass on to somebody who's maybe never done this before about trying to keep that under control? Because I remember when I was learning to weld, 70/18 vertical stringers might have been the single hardest thing for me that I learned.
Yeah, I think rod angle and stick out, arc length, are the 2 biggest things. So you're gonna wanna be relatively close. Rule of thumb is the diameter of the rod that you're welding with is the distance that you wanna be away from the plate. So for instance, you don't wanna be way out here. You also don't wanna bury it in. And that push angle is about 15 degrees. So straight up kinda doesn't work out that well, so you might wanna push it up just slightly and keep really nice and tight, about 3/32 of an inch away from it.
Perfect. And just as a friendly reminder for those that don't know, when he means 3/32, he means the wire part of the rod, not the big bulky white flux part.
Yes, that is correct. It is the diameter of the actual metal that you see down here.
Yeah, cool. All right, let's see it. Wow, that's really flat.
What you're looking for here is penetration on both sides of the bevel. Nice flush weld. Like Chucky was saying, you don't want the weld to be super convex, meaning like a mountain or a hill, because then you will have slag trapped on the side. So amperage, rod angle, all that stuff got to take into account. So yes, between 75 and 95 is a good amperage for a 3/32 rod. So I want to talk about tie-ins for just a second. Instead of coming down to the bottom of that valley, you want to come to the top of the crest, because that's where your weld stopped. So we're going to come down, swoop in, hold for a second, and then go straight up and finish it out. All right, so we put our 3/32 root pass in. What we're going to do here now is I'm going to switch over to an 1/8 rod. That's a 1/8 diameter electrode. What we're going to do is we're going to start to weave a little bit. There's a couple different ways you can do this. You might have some guys tell you they got to be stringers. You might have some guys tell you they've got to be weave. So what we're going to do is we're going to fill this up a little bit with weave until we get to about 3/4 of the way out, and then that will be too wide to weave. Then we'll start running stringers. The reason why I teach my students how to do this is because it does a couple of things. Number one, you switch up diameter of your rod. You don't get comfortable with just one. You can run them all. Secondly, don't be a one-trick pony. Don't just stringer and don't just weave.
Yes.
Learn how to do both. That's the benefit of a 1-inch bevel, is you get to practice your stringers and your weaves.
Yeah, I think this is a great way to learn, because some specifications, some teachers will tell you has to be all stringers, other has to be all weaves. They'll have their reasons, but it's best to know both.
Absolutely. All right, so now that we've got our pass after our root, our hot pass, now we can really kind of accentuate that weave, if you will. You can kind of see that weave now. So now, again, as if you've watched some of the other videos that Chucky's done, we're gonna go back to a Z pattern, which is gonna look like up on the right, straight on the left, up on the right, straight on the left. So we're gonna go side to side and work our way up. And then once, like I've said, once we've come out about 75%, then we'll start running stringers again.
And you're doing it this way because you're right-handed, right?
Yeah, so if you were left-handed, you would want to come up on the left and straight on the right. Up on the left, straight on the right. It's your dominant side that you want to come up on. All right, so we put a couple passes in now of the weave.
Wait for it. All right, now.
All right, so we put a couple passes in on the weave now with the 1/8 rod. At this point, you're more than welcome to switch between 1/8 and 3/32 and 5/32. But you know, the goal here is to get good at all of them. So if you're bad at one, I'd probably say practice with that one. If you're testing at school, you know, whatever your instructor is saying. But the main thing you're looking for is consistency as you're going throughout the bevel. Also, don't do that and have a big, massive arc mark outside the bevel. Obviously for practice and just for illustration, we're okay. We're not bending this. It's not getting x-rayed or inspected. But when you're at school, you're taking this test, you want to keep those arc marks contained to the bevel. Because that is an automatic fail if you do that.
Yeah, so there's a good chance it'll open up if it gets bent. And what would you say the best way is to avoid things like that in your restrikes?
Always start your rod at the top of the bevel and come down. Or you can start at the bottom of the bevel and go up. But always on the backing strap or on the edge of the bevel, never outside.
Yeah, you want whatever arc strike you have to be in the bevel so it gets reconsumed or something, right?
Absolutely, yeah. You want to cover it up, yes, because Chucky's right. I've seen a lot of tests tear, even when that's ground out. What happens is you put the plate under stress, and where it was arced on, it'll tear right there, believe it or not.
Isn't it like because it heated up and cooled too quickly or something?
Creates a weak point in the metal,
Kind of
absolutely.
like ducking it.
Yep, exactly, just like that. All right, so we have basically weaved our way out of this hole. What we're gonna do now is we're gonna start stacking stringers in there. So that's basically it. Weave your way out and then get yourself to a point where you can comfortably weld some stringers in there.
All right, do you have any tips for doing stringers across a wide expanse like this?
Yeah, I mean, you're gonna wanna tie into the edge here, and then every weld you put in, you're gonna tie the next weld into that previous weld. So the rule of thumb is overlap the weld halfway, tie into the toe. So the toe of this weld will be right here, so we're gonna put a stringer up there, then we're gonna do a couple in the middle, and then tie into that toe, but always tie into the previous toe of the weld.
All right, so you're saying you want the high part of the new pass to be about level with the high part of the old pass without a sharp valley in between.
Absolutely.
Cool.
Yeah, it's a good way of putting it.
All right, let's see it.
All right, so we have stringered ourselves to the cat. Now, all our welds are tied in. We don't have any slag trapped in on the sides. So those are good visual aids and cues to look for. And what we're gonna do right now is we're going to cover up the edge, tie in all the welds just like this. We're basically gonna replicate these 4 welds, and add 2 more on the sides to eclipse the edge.
Nice. So it looks to be like you've left just enough of the bevel edges to see so you can tie into them, and you've made it a point to make it so the welds aren't taller than the face of the base metal here.
Absolutely, yeah. So what you want to do before you cap is you want to work the welds out to be flush. So a good aid is you can come by and look. You don't have any highs or lows dipping out or dipping under. And what you want too is that edge, like Chuck mentioned. You want the edge here so that way when you go to tie your weld in, you strike off, you cover up that edge, work your way to the other edge and cover that edge up. It's just visual aids to use so that way when your hood is down you can see better.
Nice.
All right, so basically what I'm gonna do is I'm gonna cover up that weld, or that edge, I'm sorry, with this rod. So general rule of thumb is take that flux and kind of split the edge with it.
Nice.
If you're too inside, you probably won't, the puddle won't roll over enough. So what I try to do is just kind of split that edge with the rod and then do that with the previous welds and those that come after it. Yeah, the final one's probably the easiest one. You can see that edge right there. You know, that's the easiest visual aid in my opinion. But you can see we've got all these welds tied in nice and even with a hump going all the way through. That's what you're looking for. You're not looking for any slag or anything trapped, any low spots really. Consistency is the key when passing a test. So we're gonna put this final weld in and get a look at it when we're done. Main things to look for on the cat: undercut, fusion, slag, you know, the general stuff. So we've got a nice 5-stringer cap working here. No undercut on it, no trapped slag, complete fusion of the bevel. Obviously things could always be better, nothing's ever perfect, but as far as passing a test goes for a D11 structural 7018 uphill, that's kind of what you're looking for. Nice tied in welds, even above the surface, not too far out, not over a 1/16, a good height, under 1/8 of an inch above flush with the base metal. So there you have it.
Cool. Thank you very much.
Yes, sir.
Thanks in the description. That'll be great. That's well something else.